Hi everyone. The first lab for this week will be over pH. This will be our first wet lab, and I think you'll have some fun with it. So I just wanted to first go over a few things with you and hopefully make your life a little bit easier when you go to actually do the lab. So to start out with, let's just start from the blackboard, and you will see the reading assignment along with the report sheet and a place to turn it in. What I've done below that is I've gone ahead and taken out my lab kit, and I have taken a picture of everything that you'll actually need for the lab. And I've gone ahead and labeled it just in case you aren't quite sure what some of the things are. Like maybe you weren't quite sure what a well plate is. Probably you know what a beaker is or a pipette, but you might not have known what a well plate was, things like that. So I've just gone ahead and pictured everything here for you. So just starting from the left, this is a disposable pipette. You can just use one of these for the lab. You will just need to rinse it every time you use it, pretty much. But this is not a real sensitive lab, so just using one of your pipettes should be totally fine for this lab. But you'll just need to make a waste beaker and a rinse beaker and just suck up some clean water and then shoot it into the waste beaker, and just do that each time you use it for a different chemical, and that will be totally fine for this lab. Next to that is your spatula or scoopula. So the flat end is the spatula, the sort of spoon type end is the scoopula. Use this to get chemicals out of their container, things like that, or stir things. Next to that, we have a well plate. So this is where you'll actually be conducting this experiment. So when you're finished, you'll actually have filled each one of these little wells. Okay, so there's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. Okay, so you're going to fill all of those by the time this lab is finished. Above that, you have your safety glasses or your safety goggles. So make sure you wear that for this lab. You are going to be dealing with some acids and some bases for this pH lab, so do make sure you protect your eyes. Next to that is an Erlenmeyer flask. That will be essentially where you store your indicator that you're going to make in this lab. Your two 250 ml beakers, your 150 ml beaker, and then of course your hot plate. Okay, so one thing I would like you to notice with this equipment is that I have everything is glass except for the well plate and of course the spatula and the pipette. So the important thing here is that your hot liquids will only go into your glassware. Okay, so you also should have a plastic beaker. You won't be using that for this lab. So when for instance, when you're going to end up boiling red cabbage to make an indicator, when you do that step on your hot plate, don't use your plastic beaker, right? Because it can melt. I know that probably seems obvious, but just to make sure use your glass beakers. Those aren't not any kind of special plastic that's heat resistant. You're going to want to use the glass stuff. Okay? And if you don't have, maybe if one of your beakers came broken, maybe you don't have the smaller one. These are just, so one is to actually cook the cabbage in. The other two are just for rinse and for waste. So you can use a different container if you don't have all three beakers. That's totally fine. And then again, if you don't have the 250 ml flask, if that one came broken, you can use something else to house it in. This is just a convenient way to store things. That's all. The only reason that we're going to use that. Okay, so you also need your hot plate, and then, and I'm suggesting here an oven mitt or a pot holder. And that's just because you're going to boil something, and then you're going to turn off the heat, and you're going to let it cool. But if you get a little anxious, maybe it might still be hot, but you should let it go down to room temperature. But if you do end up needing a pot holder or oven mitt, that'll come in handy. Okay, down below that, I've gone ahead and taken a photo of all the chemicals you'll need for the experiment. So the only thing that's missing from these chemicals is the red cabbage, which you can get from the grocery store. And then you need vinegar, or if you have a jar of pickles, pickle juice will be just fine. Okay, so vinegar is acetic acid. That's what's used to make pickles, and if you just buy white vinegar, any of that will be perfectly fine. Okay, so that's just to give us something on the acidic side. So we need ammonium chloride, polyvinyl alcohol, sodium bicarbonate, sodium borate, and sodium carbonate, and then you should have a dropper of universal indicator. And then on top of that, you need red cabbage, and you're only going to use a quarter of this at most. So if you have a friend that lives nearby that's taking this class, you guys can share. That's totally fine. And then vinegar, or pickle juice, as I said. And you can buy small bottles of vinegar for just a few dollars. But if you have a jar of pickles, that will work fine too. Okay? So hopefully that will kind of let you know everything you need and what exactly everything is. And then let's get into the actual experiment sheet. So I won't labor this too much, but we have an introduction, so you can read through this, and it just sort of sets up the purpose of the lab and what we're actually doing. So we're going to look at pH of some household chemicals. Okay, so you can see the name, determination of pH of household chemicals. So basically you're going to create 2 color standards, and then you're going to find some things around your house. I give you a suggested list, but you can work off the list as well. But you'll find some things around your house, and you will test their pH, and then you will be able to find their pH using your color standards, and you'll be able to compare them that way. So pH is the log of the, or the minus log of the H plus, in other words, the hydronium ion or a proton. So this is what exists in acidic solutions. So the more H plus you have in solution, the more acidic it would be, which would be a pH closer to 1. And the less H plus you have in solution, the higher your pH will be. Okay, so the less acidic, so closer to things like 14. Okay, and it talks about some of that in your introduction here. I mainly wanted to talk with you about, and then you have an equipment list, a chemical list. This is acetic acid, just in case you're not sure. CH3COOH, that's acetic acid, or vinegar, in other words. Okay, and I just wanted to quickly go over the procedure with you. So the first thing you'll do is you will want to get out your hot plate and your beaker. Go ahead and gather all your glassware, would probably be a good idea, all your chemicals, just get them all ready. And then take out your red cabbage, and you can either cut a chunk of it off or rip some leaves off of it. Either way, it doesn't matter. But you just need to shred this by hand. It doesn't need to be real fine. So just roughly shred it so that you can fit it into the beaker. And you're going to fill it up to about the 150 ml mark. So somewhere around in. So this would be 100, 150. Somewhere around in here. Okay, then you'll put water on top of that. So just tap water is fine. And you'll fill it up to the 200 ml mark. Okay, then you will put this onto your hot plate and turn it on to a relatively low setting. So, don't just crank it all the way up to the highest it will go. That can get out of control very quickly. If you ever used an electric stove, you know that once things start getting hot, it's very hard to cool them down quickly. Okay, it takes a long time for an electric stove to get hot. It takes a long time for an electric stove to get cold. So think about it that way. So just turn it on to one of the lower settings, maybe mid-range, but absolutely do not crank it as high as it will go. That can get out of hand. So just put it up maybe halfway or so. And then you're going to slowly boil the water. And once you start to see it simmer or boil, you can go ahead and turn the heat off. So by no means do you need to have a roaring boil. So you don't need to even bring it to a boil for very long. So just heat it long enough that you start to see steam and bubbles, and then you can turn your heat off. Okay, then allow your mixture to cool. And when I did this, I believe it took about 30 minutes to cool all the way down to where I could pick it up with my hands. Make sure you sort of place your hand near to it and don't just grab it to make sure it's not too hot. And if you're not sure, you could use an oven mitt. But you shouldn't see any more steam. It should just look like, a normal beaker of water with some cabbage in it. But what you will notice is that the water should turn this deep purple color. So what that's doing is that's extracting the indicators from the cabbage. Okay, but remember that hot glassware looks exactly the same as cold glassware. So you need to be very, very careful not to just reach and grab it when you're not sure whether it's still hot or not. So just like if you were testing an iron to see whether it was hot or not, you could put your hand very close to it without actually touching it, and that will let you know if it's safe to pick up or not. Okay, so just be very careful, and this is really the only stage where you're going to be dealing with anything hot. So be patient in this step, and once you have this solution cool, what you'll do is you'll decant it into your Erlenmeyer flask, and that just means to pour the liquid and leave the cabbage behind. You could also just pipette the solution directly out of the beaker if you would like to. This just makes it a little bit cleaner, so you don't have any chunks of cabbage floating in there. Makes your life a little bit easier. But it's sort of an optional step, but I would suggest decanting into your Erlenmeyer, because that way you don't have to worry about your pipette getting clogged with cabbage or anything like that. And depending on how finely you shredded your cabbage, this may be more important than not doing it, but I would suggest go ahead and decant into your Erlenmeyer, and you should end up with this nice deep purple solution. Okay, so that's the first step. So this is the preparation of York indicator. So what you've created with this now is you've extracted a universal indicator that actually is housed inside of the cabbage. And that exactly what that is and how it works is in your introduction. I'm not going to get into that now. But what you've done is you've actually extracted that indicator. Okay, so the next thing you want to do is you want to prepare your color standards. Okay, and so the first thing you want to do is you want to get your well plate, make sure it's clean and dry. And you're going to fill 6 wells in one row, halfway with water and halfway with cabbage indicator. So this top row, you see the purple, that's all 50% cabbage indicator and 50% water. And what that does is it makes the colors kind of pop a little bit better. So if you just put pure cabbage indicator, the solutions end up looking a little bit dull when you actually add the other things to them. So if you dilute it 50% with water, it makes the colors pop a little bit more. And then in the second row, so the second set of 6, you'll put fill it 80% of the way with water, and then add about 2 drops of your universal indicator. And remember, that comes from this bottle. So just add a couple drops, and it should have this color standard along with it. That's what we're going to use to actually determine the pH. Okay, so once you have those 2 rows set up, it asks you to recreate table 1. Okay, it says recreate table 1 by adding a small amount of each chemical to the different wells in the same order they are listed. Okay, then it wants you to mix them, and then it wants you to complete table 1 by filling in the information that it asks for. Okay, so let's jump to our other document, and let's look at table 1. Okay, so here's table 1. So the first thing it wants you to do, and I actually put these out of order. I maybe should have put them the other way around. But the first thing it wants you to do is the commercial indicator, in other words, the universal indicator, and your cabbage indicator. And what it's asking you to do is to each of these rows that you just made, so one's cabbage and one's the universal, you want to fill in the information for each of these solutions. So the first 2, so for the commercial and the cabbage, the first 2, you'll add acetic acid or vinegar. And then on the next set of 2, you'll add ammonium chloride, and etc. down the line. And so these 1, 2, 3, 4, 5, these are solids, whereas this first one will be a liquid. Okay, so this one, just add a few drops, and maybe you can stir it up a little bit if you need to. These other ones, just add a very small amount, and you should see a color change. And so what you're going to end up doing is writing down the color that you see for the solution. So is it pink or blue or green? And these will be shockingly different. You'll have no question about what colors you're seeing if everything goes right. So you'll do that for both the cabbage and the commercial indicator, and that will give you some data in terms of how to determine the pH. Okay, so how are you going to do that exactly? Well, since we know the pH of the commercial indicator, this way we can compare it to the cabbage indicator, and this will tell us what color the cabbage indicator is at that particular pH. So how do we know the color of the commercial indicator? Well, if we come back to this photo, this little label that you can pull off is actually a color standard. So it will tell you if it's orange, then it's this pH. If it's yellow, then it's this pH. And you'll just go through them, and you'll be able to determine the pH of each of these solutions that you make. And so then you'll know, okay, if my universal indicator is green and my cabbage indicator is green, then it's this pH. And it doesn't matter if the colors line up. You're just going to look at that's the color that it is when it's this pH. So one could be green and one could be orange. Okay, so it just depends on how the indicators respond to the pH values. Okay, so you'll go through and you'll do that for each one. So write down your colors and then determine the pH using the commercial indicator. And now you'll know what the color of your cabbage indicator is at each pH. Okay. So jumping back to our experiment sheet, so part 3, or part C here, I should say, you're going to determine the pH of household chemicals now. And the way you'll do this is you'll first repeat steps 2 and 3 from part B using 2 new rows. Okay, so you come here to part B and come to step 2 and 3. It's basically going to ask you to do this again. Okay, so it's going to ask you to make 2 new rows, one with cabbage indicator and one with universal indicator. Okay, so once you do that, what you'll do is you will come to the list in your report sheet. So down here below, come to table 2, and this is your actual household item test sheet. So there's lots and lots of things here, and I tried to find things that I thought you would readily have in your house. So I really don't intend for you to have to purchase anything for this section. So hopefully you have some type of antacid. So that could be Pepto-Bismol or Tums or anything like that, solid or liquid. Anything like that would be just fine. Carbonated soda, so this could be anything from Coke to Sprite to Pepsi to Dr. Pepper, whatever it is that you have in your house. Pickle juice, if you didn't use pickle juice to make your standard solutions, here's a chance you could use it. Bleach, if you do end up using bleach, be very, very careful. Remember, it's bleach. It could stain your clothing and burn your skin, so just handle it with care if you do end up using bleach. Milk, distilled water, glass cleaner, detergent, lemon or lime juice, shampoo, mouthwash, orange juice, apple juice. You could test your own tap water if you wanted to. If you have hot sauce, coffee, baking soda. And then the last one here, I gave you just other. And what I mean by other is anything else you would like to test. Okay, so if you have something you're interested in, maybe it's just something you're interested to see what the pH is, you can put that in the other slot. Or maybe you don't have enough of these. So I believe I asked you to do at least 5 of them. Let's see. Yes, I ask you to choose 5 and just test their pH. Okay, so you won't quite fill up a whole row here. 1, 2, 3, 4, 5, 6. And that's important because in the last step we're going to, so the last set of wells should be still just full of universal indicator and cabbage indicator. And that's because we're going to add, we're going to mix 2 of our solutions together in the last part. Okay, so go through and select 5 of the chemicals, or again, 1 maybe you just choose on your own as the other. And just test their pH in 5 of the wells. And you will come to this table and just fill in, so fill in the color for the commercial indicator, the color for the cabbage indicator, then tell what the pH is. And if anything interesting happens while you're doing this, you can write comments down. So for your other, you could write down what exactly it is you're doing. And for the comments, just anything you observe that might be interesting, you could write here. So don't feel like you have to write something for every single one, but if there is something interesting you notice, you could write it down here. Okay, so the last step, we're going to actually combine an acid and a base. So this is step D. Okay, so what I'm asking you to do here is to choose 1 acid and 1 base solution from the household items you tested. In other words, choose one of these that showed up in acid and choose one that showed up as a base. And what we're going to do is we're going to mix those together now. Okay, so you choose 2, so choose an acid, choose a base, and then in the last 2 wells that you made, so one has cabbage indicator, one has base or universal indicator. So you'll take a little bit of the acid solution, put it into each one, and then put a little bit of the base solution in each one, and then mix them together, and note what happens to the pH. So you'll want to first be sure you know what the pH and the color of each solution was before you mix it, and then mix them together, and then you can see what happens to the pH. So does the pH go up? Does it go down? Is it neutralized, meaning close to 7? Or what exactly happens? So here I ask you to mix them, and then note their color, and then determine their pH. And so all of that data will go here. So just here tell what substances you're choosing. So is it acetic acid? Is it lime juice? Or what is it? and then what color is it for the indicator before, and what color, what's the pH of that, and then once you combine them, write down what color they are and the pH. And for the color section, you can write down both the cabbage indicator color and the pH, the universal indicator. I didn't quite give you enough space there, did I? Okay, but you can write those down, and you will be able to determine the pH of your mixed solutions. And just observe what happens there. Okay, and the last section here is just waste disposal. So everything we've used can safely go down your sink. Vinegar is safe to go down the sink, and then all the household chemicals, just dispose of them as you normally would. Any excess powders you might have in the wells or anything like that, just rinse the wells thoroughly and flush everything down the sink. And then clean all your glassware and dry it. And you do want to clean this right away, because if you don't get the cabbage out of the beaker or the flask, it will actually start to mold over time if you leave it long enough. So you could keep it for a day or two if you want to play with it, but you do want to clean your glassware because it will stain it. But everything is safe to go down, go or be disposed of with your normal waste. So it's a liquid, just flush it with lots of water down the sink. If it's a solid, if you have a leftover tum, throw it away the same way you would normally a leftover tum. Okay, and then just make sure you clean up your counter or wherever you just choose to do this at. And I would suggest laying down some newspaper or some paper towels just to catch anything that might spill. If you have some aluminum foil, that's a good idea. So anything like that, because it won't leak. But anything like that, just make yourself a nice work surface, and then you can do the lab. And then the last step here, I've asked you to just attach a photo of your well plate, just so I can see what you did. And then there's some questions here for you to answer. Okay, so I would suggest not waiting until the last minute with this one, in case you have some questions. So I know this is our first wet lab, so I expect you guys to have some questions. Please feel free to email me. Come see me in my office hours. Again, if you need some extra help, I'm happy to meet with you. But hopefully you will enjoy this lab, and you'll have some fun with it. I think it will be interesting, and hopefully you'll learn a little bit about pH. So I thought this was rather fun when I did it, and hopefully you will too. Okay, good luck, and let me know if you have any questions.